This lesson is going to be on rational exponents. So we're used to seeing variables with like a square root under it or over it, radical sign, or cubed root, or fourth root, or something like that. But what does it mean if we have like an exponent in fraction form? So let's say we have n to the half power. Well, what that means is that's the same thing as the square root of n. So really there's a 2 there, they just don't put it, but that's what that means, the square root of n there. So if we have n to the third power, then that'd be the cubed root of n. N to the fourth power, or excuse me, 1/4 would be the fourth root of n. And let's see, what if they had n to the 2/3? That means that the bottom number, that one in the denominator, the 3, that number always goes on the outside, so that's the cube, that's the index. Then the variable, and then the numerator, the number in the top, goes inside there, so that'd be like that. So that's a cubed root of n squared. Let's try another one here. So that'd be to the 4/5. So once again, the bottom number goes outside in the radical, and that's the index, and then the top number in the numerator there goes inside there. So that'd be the 5th root of n to the 4th. So let's try a couple examples here. Let's say I have 16 to the 3/4 as my exponent. So that means the bottom number, the 4, the denominator, is your index. Then it's the top number goes with the number underneath the radical sign there. So that means the 4th root, and 16 to the 3rd power is 4096. And then if you take the 4th power, or excuse me, the 4th root of 4096, then you would get 8, and that would be your answer. We'll try one more here. Let's say I have 27 to the 4/3 power. Alright, so we got 3 there, 27 to the 4th. Now this is going to come out to be a big number because 27 to the 4th power means 27 times 27 times 27 times 27. So it's 3, which is 531,441. And then if I put that in my calculator, the cubed root of 531,441, or the to find out what that is, and that comes out to be 81. So that would be a couple examples when if you have a problem like that. That's how those are set up and those are solved. Alright, the next example, we're going to have a fraction. Let's say it has a negative exponent. So let's say I have 16 over 49, and that's to the negative 1/2 power. Well, all we have to do there is just flip our fraction, not the negative 1/2. We're going to leave that alone. We're going to flip the 16 over 49. Normally we'd put a 1 over it. It would normally look like this. And then we go and solve it from there. Then we'd have the square root of 16 and the square root of 49. So we have 1 over 4/7, and that says 1 divided by 4/7. 1 divided by 4/7, which is the same thing as 1 time, or we change it to multiplication and flip the second one, same change, flip, you probably remember that, 7/4, so then I'd get 7/4 is my answer. But there's a little bit easier way to, instead of looking at all those steps, or doing all those steps, that there's a couple steps and then you're done. So the other way would be just take your fraction, flip it, take away the negative, so it just looks like that. So you had a negative 1/2 and you had 16 over 49. Just flip that fraction inside, take away the negative on the half. then you're going to write it as the square root, because remember the half is, if you remember from the very first slide, a number to the half power means the square root of that number. So we have the square root of 49, square root of 16, because you can take the square root of the numerator and denominator, you can separate them like that. It doesn't have to be all in one fraction. It did start out like this, but we can write it as in this form here. And then all I do is take the square root of 49, square root of 16, so that's 7/4, and that's where I get my answer there. Alright, let's try one more of those. So you have 8 over 125. That's a negative 1/3 power. Whoops. Sorry about that. And then we're just going to flip that, so we'd have 125 over 8 to the third power. So that's going to be the cubed root, because remember that denominator number goes in, is your index, 125, and the cubed root of 8, and the cubed root of 125 is 5, and the cubed root of 8 is 2. Because 125, what times itself 3 times is going to give me 125, it's 5. What times itself 3 times is going to give me 8, which is 2, so then that would be my answer. Alright, so our next type of problem is 30 over 5 to the 3/4 exponent there. So we need to get rid of that 3/4 there. Now if you remember, 5 to the 3/4 is really the 4th root of 5 cubed. So there's a radical sign in the denominator, and you can't have that in the denominator. It has to be simplified. There can't be any radical signs underneath in the denominator position. So we need to get rid of that 3/4. So we really want it just to look like a 5. That's all we want there. We want to get rid of the 3/4 and make it a 5, or if you want to think of it as 5 to the first power. So really we're trying to change that 3/4 to 1. So what could I put with that 3/4 to make it 1? So 3/4 plus what is going to give me 1? Well, it'd be 1/4. Because 3/4 and 1/4 is 4/4, which is 1. So in order to get that, we're going to multiply this by 5 and 1/4. Because way back when, if you remember, if I have a number to some exponent times that same number to a different exponent, I just add those together. So that was one of the rules. If you have two numbers or two variables that are exactly the same and they're exponents, then you just add their exponents, and that would be your answer. Alright, so we have 5 and 3/4 times 5 and 1, excuse me, the 1/4 power. And whatever you do the denominator, the bottom, you have to do the numerator. So we're going to take that also up there. So then I have 5 and 3/4 times 5 and 1/4. 5 and 3/4 plus 1/4, because of this rule way down here. Same number there, and then the base, so we have a 5 a base, just like we have the ends here as a base. So our base is 5, and our exponents are 3/4 and 1/4, which equals 5 to the 4/4, which is 1, but you don't need to put the 1, just leave the 1 off, so it's really just 5. So on the bottom now we have 5 to the first power of 1, you don't need to put that, so just 5. And then on the top we have 30 times 5 to the 1/4 power. Alright, to clean that up, then we're going to look at this right here, just like you learned way back in elementary to simplify fractions. That is 6, and then I still have the 5 and the 1/4, so then that would be my answer. You cannot take 6 times 5 and multiply to get the 30, and the reason why is because 5 to the 1/4 power really looks like this. So really this is what your answer would look like. So that's why you cannot take 6 times 5 and get 30. So your answer was the 6 times 5 to the 1/4, or to clean it up a little bit, it'd be 6 and then the fourth radical, or excuse me, fourth root of 5. So that's how you'd write that. Alright, let's try one more of those. So we have 24 over 6 2/3. Alright, so once again, we need to get rid of that 2/3. We need to make it 1. Well, 2/3 plus what is going to give me 1? It would be 1/3. Because 2/3 plus 1/3 is 3/3, which simplifies down to 1. So we need to use the 1/3. So we're going to use the same base, 6, to the 1/3. Whatever you do to the bottom, you have to do to the top. Alright, so we have that. So now 6 2/3 times 6 1/3. So you add since we have the same bases, we add our exponents, and we get 6 3/3, which would be 6 to the 1, because 3/3 is 1, 3 over 3 is 1, or just 6. So just leave it as 6. You don't need that. Alright, so we have 6 over here on the bottom. Then on the top we have 24 times 6 1/3. Alright, then simplify it a little bit. Look at that right there. 24 over 6 simplifies down to 4, and we still have the 6 1/3. And there would be your answer. Now once again, you cannot multiply 4 times 6 and get 24, because really what this looks like is the cubed root of 6, because remember from the very first slide that 1/3 power is just like the cubed root of a number. So that would be my answer then. Alright, so these are last type of problems here. So we have m to the third, v to the 3/4, and z to the 5/6. Alright, so in order to simplify this, we need to get all of those fractions with a common denominator. Once again, you've done this way back when to find common denominator. So our common denominator for 3, 4, and 6 would be 12, because that would be the common denominator. So in order to change that, we're going to have 1/3. So what would that make it for common denominator of 12? Well, that means I have to multiply that by 4, so I have to multiply this by 4. So it would be 4/12. And for v, let's go back to black here. Let's see. Oh, that's right, we just do that. There we go. Go back to black here. 3/4, and our common denominator is going to be 12. So what did I multiply? Whoops, that should be 12. What did I multiply the denominator by to get 12? 3, so I have to multiply the top by 3, so that'd be 9. And now we'll do the z. Z to the 5/6. Alright, z. We've got to change that to 12. So I multiplied that by 2, so I have to multiply this by 2, so that'd be 10. Alright, so now to clean it up a little bit, I have m to the 4/12, v to the 9/12, and z to the 10/12. So now I have them all with a common denominator, and I'm going to write them using a radical sign. So once again, the number on the bottom, the denominator, the 12, goes on the outside, and the numbers in the numerator part go inside with the variable. So that'd be 4th, v to the 9th, z to the 10th. And now we're going to see, just like we did a couple lessons ago, how many times does 12 go into 4? Well, it doesn't. How many times does 12 go into 9? It doesn't. How many times does 12 go into 10? It doesn't. So then that is just your answer. You're just going to leave it just like that, and you can't do any more than that there. Alright, so let's try another one here. So we have a to 2/3, n to the half, m to the half. So our common denominator will be 6, because that's what 2 and 3 have in common. So it'd be a, and in order to get 6, I had to multiply this by 2. So I have to multiply this by 2, so that'd be 4. Then I have n, the common denominator is going to be 6. So I multiplied this by 3, so I have to multiply this by 3. So that's going to be 3. Then I'm going to have m 6 and multiply that by 3, so I have to multiply the top by 3, and that's also going to give me 3. Alright, so I have a to the 4 6, 3, n to the 3 6, and m to the 3 6. They all have a common denominator. So I'm going to write that using a radical sign. Bottom number goes on the outside, top number goes with the variable. And then I ask myself, how many times will 6 go into 4? It doesn't. How many times 6 go into 3? It doesn't in either one of them, so then that would be my answer there. So next we're going to look at one where if the index, like the 6 on here, goes into or is divisible by one of the exponents underneath the radical sign. Alright, so here's our next problem. So we have a denominator, so 3, 4, and 2, so we're going to find a common denominator. That would be then, let's see, probably 12. Alright, so we're going to have a, and this has to be at 12, and this has to be at 12, and c, this has to be at 12. Alright, so I multiplied this by 4 to get 12, so I have to multiply that by 4, so that'd be 8. Multiplied this by 3 to get 12, so I have to multiply the numerator by 3, so that'd be 3. And multiply this by 6, so I have to multiply this by 6, and I'd get 18. Alright, so now I have the common denominator. So our index would be 12, then I have a to the 8th, n to the 3rd, c to the 18th. Alright, so 12. So let's look at each one. How many times will 12 go into 8? Well, it won't, so we just write it again. How many times will 12 go into 3? It won't, so we write it again. How many times will 12 go into 18? We'll go in there one time, so we got a C out there because it goes in there once. And then I have 6 left over, because 12 up to 18 is 6. So I have C to the 6th. And then that would be my answer then. That's as farthest as I can go. Alright, one more example here then. So let's see, we got a 2, a 4, and a 5, so our common denominator probably is going to be, looks like probably going to be 20. So we have x, and this is going to have to be a 20, y, that's going to have to be a 20, and z, that's going to have to be a 20. Alright, so I multiplied this by 10 to get 20, so I have to multiply that by 10. So that'd be 10. 1 times 10 is 10. Multiply that by 5, so I have to multiply that by 5. So that'd be 15. Multiply that by 4 times 4, 24. Alright, so now we have our numbers with the common denominator. So we have the 20 on the outside, because the denominator always goes outside. X to the 10th, y to the 15th, z to the 24th. And now to see if I can simplify it any further. 20 goes into 10. Nope, it doesn't, so we're going to leave it out there, or inside there. 20 won't go into 15, so that's going to stay right there. And 20 go into 24 once, so we have one z out there because it goes in there once. And we have 4 left over, so the other 4 are going to stay right underneath there. So then that would be my answer. Alright, so that's the end of the lesson with all those examples. So again, please go back, watch the video if you need to again, because it has good examples, and I think the steps are fairly clear. So just don't watch it once, just don't listen to me once on there. If you have to, make it 2 or 3 times until you get it, and just watch those steps so you can see. On the next slide, you're going to have the homework problems, so we'll go right from there. Alright, so here's your homework problem. So the first one's 64 to the 2/3, then 27 over 64 to the negative 1/3, 21 over 7 and 2/3, and then number 4 is 4 to the 3rd, a to the half, c to the 5/6, and 5 is 7 to the half, n to the 2/3, m to the 11/6. So just these 5 problems, and if you're not sure where to start on some of them, please go back to the slides in this video, look at your notes. If you don't understand your notes, then go back to the slides again, because it's step by step, and I have explained step by step what to do in all those. So like I said, if you're not sure where to start, go back to that slide, watch the video again. Good luck. Thank you.